Welcome back to Sudoku Sunday, where today we are solving Modularity by Pagado. Let's jump right into the rules. Normal Sudoku rules apply. Teal lines are mod 3 lines, and along each mod 3 line, every set of consecutive 3 digits contains 1 from the set of 147, 1 from 258, and 1 from 369. So that's modulus, which means that if you divide by 3, since it's mod 3, they each have a different remainder. 3, 6, and 9, if you divide by 3, have a remainder 0. 2, 5, and 8 have a remainder 2. And 1, 4, and 7 have a remainder of 1. So we can't have, so if there's a 3 here, these next to it can't be from 3, 6, 9. They have to be either from 147 or 258. Digits in cells joined by an X sum to 10. So if this was a 2, this would have to be 8. Easy peasy. Digits in cells joined by a V sum to 5. If this were a 2, this would have to be 3 to make 5. Digits in cells joined by a white dot are consecutive, so if this was a 2, this digit would have to be consecutive or next to a 2, so that would be either a 1 or a 3. And then digits in cells joined by a black dot are in a 1 to 2 ratio. So if this was a 2, this here could either be double 2, which is 4, or half of 2, which is 1. And not all X's, V's, or dots are given. So if we had a 2 here, this could be a 3 to add to 5, or a 1 to be consecutive. And it doesn't matter that there's not a dot here, we can still do that. Now let's jump right in. The first thing I see are these little squares, because they are quite marked up. So we know that every 3 cells on a modular line is going to be the same group, which means that 1, 2, 3, 1, these are in the same modular group, and they are in a 1 to 2 ratio. We know the digits that can go on a black croppy dot are 1, 2, 3, 4, 6, and 8. So if we look over at the groups, we're trying to find 2 digits that are double each other and in the same modular group. So 1 and 4, not double. 2 and 8, they're not double each other. But 3 and 6 are in the same modular group, so we can put them there. Now we can look at this V, and 6, no matter how hard you try, you can't get it to add up to 5 with a Sudoku number. We need -1 here, so we know this is the 3 and this is the 6. 3 plus 2 is 5, and 6 plus 4 is 10, and that also works here with our black dot, and it also works on our modular line because 2 is from the 258 and 4 is from the 147. We have the black dot on the end again, so we already know that this is going to be 3, 6 somehow. We can also look at this little square up here. So these two add to 5 and are from the same modular group. 2 and 3 and 1 and 4 are our options, but 2 and 3 are from different modular groups, so we know this has to be 1, 4, which means this does have to be 2 and 3 because these have to be from different groups. Perfect. And the same here, these two have to be from different groups and add to 5, so that is 2 plus 3. And then we can do some Sudoku here. 2 and 3 both see this digit right here, which is on a V, which means it can only be 1, 2, 3, and 4, which makes this a 1, 4, and a 1, 4. And if we count 1, 2, 3, this has to be from the same mod group as this, which is still the 147 group. So we have all 3 of the 147s right next to each other. We already have the 1 and 4 looking at this, so it has to be a 7 plus 3 equals 10. Which means this is from the 258 group. We can pencil that in. And we can also say what is consecutive with 1 or 4. Not 8. It could be 2 consecutive with 1 or 5 consecutive with 4. but it cannot be 8. Let's see. So we know 2 and 3 in some order are here. So what group is this? It is the 1, 4, 7 group. 1, 4, 7. Perfect. So how do we make 10 here? Be 7 plus 3, but we can't do that because we already have a 3 looking at it and a 3 in the box. This can't be a 7. 4 plus 6 are 1 plus 9. And that means that this cell, and then also 1, 2, 3, this cell, are in the 3, 6, 9 mod group. And it already sees a 6 and a 3, so this has to be a 9, which is only consecutive with an 8. Lovely. So we have 1 from the 1, 4, 7 group here. It's going to be the 1. It has to go on the line, because if we put it outside of the line, there'd be nothing left from the 1, 4, 7 group to go on the mod line. So 1 is in one of these two places. What else do we need? We need a 1, 2, and a 5. We know this cannot be a 2. And that also gives us a 1, 2, 5 triple here, which is interesting. Alright. It's gonna be 3, 6, but they could be 1, 2, 2, 4, or 4, 8. We don't quite know yet. What about this X? Are there any sums of 10 that are in the same mod group? Yes, only 2 plus 8 equals 10 is in the same mod group. Get that. Very nice. This 10 here has to be in different mod groups from each other. It's not 2, 8, and it's not 4, 6. So this is either 3, 7, or 1, 9. So 1, 3, 7, 9. This one cannot be 3. Which means this top one cannot be 7. We already said this cannot be 1. Which gives us a 2, 5 pair. Which makes this the 1. Also means this cannot be 1, 9 anymore. This has to be 3 and 7. This order. This 3 comes across and sees the 3, 6, so that's the 6, and this is the 3. This 3 is at a 2, and that a 3, so now we know that this are 3, 6, and 9. And these two are going to be 2, 5, and 8. So 5 and 8. But a 5 can never go in an X, because 5 plus 5 equals 10, and we can't have those next to each other. So that's an 8 with a 2, and this 8 sees the 5 up here. This 2 makes it a 3, 2. 3 by Sudoku in this box goes here. Wonderful. Two looks at this 2, 5, makes that a 5, and this a 2. I look at 2's by Sudoku. 2 is here. This could be a 1 or a 4. It can't be a 1, but it could be a 4. Or sorry, this is a white dot, not a black dot. So it'd have to be a 1 or a 3, and it can't be a 3. So 2 actually is placed. It can't go here anymore. There's a 2. How many 2's are left? This one, and... Okay, so we've got an X-Wing left on 2's. Good to know. 2. We can count now here to make that from the 258 group. No more clues about that though. This can't be 2-1 or 1-4 or 1-2 anymore, so it has to be black dot eligible digits from 2 separate groups that doesn't have a 2, which means it has to be 4 and 8. We don't know which way yet though. 3 group and 7 group are taken up, so this is also from the 258 group, and there's not a 2, so it's just 5-8. That's an X-wing on 8s here actually. There's 2 8s for 2 rows, so there can't be an 8 in any of the rest of these places. Which means 8 is in one of these 2 cells, but we already know it can't be here because this is not in the modular group with 8. 8 has to be on this modular group. So that actually gets us our 8 here and our 2 here. And our 2 here. That is the end of our 2s, which is quite nice. Take a look on 3s. We're almost done with 3s also. We do any last Sudoku on them. Not quite. Click through, we only have 1 4 and 2 5s, but getting close on 5s. Six, only 2 6s. 2 7s. 7's over here. If a 7 was here, this could be not 8, but it could be 6. That is allowed. I don't think we have enough of 8s or 9s to do anything either, but it's always good to check every once in a while. Alright, let's look at this 10 sum. So it can't be 2 8, it can't be 4 6, it can be 3 7 or 1 9. Once again. And it can't be 3 7 because a 3 cannot go in here at all. So 3 7 is taken out. This is a 1 9, which means between these 2 digits we have a 3 and a 7. This 2 actually sees this 2 5. That's something we just missed. 5 is consecutive with 4 plus 1 equal to 5. The 4 here plus 6 is equal to 10. So somewhere in here is something from the 369 tree. It means these 2 cannot both be from the 369 tree, and they also can't both be from 258 because we already have 2 258s around here, which means these are from 147. That is not a 4. In fact, all 3 of these that are left are from 147. So if this was 1, this would have to be a 2. That's not allowed. If this was 4, this could be 5 or 3, and neither of those are allowed. So we know this is the 7 actually, which is consecutive with 6 because it can't be consecutive with 8. Let's take 7 out of here. It also makes this part of 147, but it can't be 7 and it can't be 4, so this is a 1. 7. 3 goes here. Now we have only one more digit left in this column. It is a 9. Makes this a 6. And a 9 here. This sees a 1 and a 4, so it's a 7. This is between 1 and 4, and I don't think we know which one it is. This is from 147 as well, and it's not a 7. Lots of 1-4s all over. We need 5, 8, and 9. Around here, 9 by Sudoku. This goes here. It's 5, 8. And we already see an 8, so that's the 5. And that's the 8. This 8 comes over here. Gives us the 4, 8. This 4 is going to do a lot. Or at least a little. Tighten up our 1-4 problem. Only one digit left in this row. That's a 9. Which is only consecutive with 8. And this is also a 9 because it's from 3, 6, 9, and it already sees a 3 and a 6. That's the 9. This is the last in its row. The 5 means this is from 147, and it's not a 1-4, so it's a 7. Perfect. What is left here? 1, 2, 3, 4, and 6. And those add to 10, so this one is going to be 4, 6 as well. Okay. This is the last in its column. 2, 3, 4, 5, 6, 7, 8, 9. This one goes here. So this is from 2, 5, 8, and it sees a 2 and a 5, so it is the 8, which gives us a 5 here. 1, 4, and 6 go here, but not 4, so just 1, 6. Not 6 either, so that's just a 1. 4, 6. It's 4 gives us a 1 and a 4. This 6 over here gives us a 4, 6. This is now from 147, and it sees a 7 and a 4, so it's a 1. Let's see. This one sees the 1, 9. This is from 147, and it sees a 1 and a 4, so that's a 7. This is from 2, 5, 8, and it sees a 2 and an 8, so it's a 5. This is 1, 2, 3, 4, 5, 6. Also 9. This is 8. 3, 7 sees a 7, so that's a 7. Or sees a 3, so that's a 7, rather. What is left in here? 3, 6, and 5. And these two have to be the same group. So the 5 is here. This is 3, 6. The 6 goes here. 5 is consecutive with 6 and 4. 6 is taken, so that's a 4. This is from 3, 6, 9. It sees a 9 and a 3, so it's a 6. So the last in the box, 8. And then the last digit in the puzzle is a 7. Thank you for solving along with me. That was Modularity by Pagado in 19 minutes and 14 seconds. I'll see you guys next time. Until then, bye-bye!